Number 34, so we have a hyperbola, 9x squared minus 16y squared minus 16y minus 208. So we can see here we don't have any other x's, but we do have these two y's, so we can do a complete the square in order to get a perfect square for that one. So we'll have 9x squared minus, now we can put these y's together, and I'm going to go ahead, I'll show it here, and add this over. And what we're going to do on the next step is factor out a 16 from here. And so we've got step 2, 9x squared minus 16. Now, that's going to leave me y squared plus 4y. I took out a negative 16, so this has to be positive. Negative times positive equals negative. And then I want to complete the square, so I'm going to leave a box space there. This equals 208 plus whatever I added in that box. So half of 4 is 2. We take half of the b value. That's 2. 2 squared is 4. But over here, I need to multiply my negative 16 times 4 in order to add it to the other side. So negative 16 times 4 is equal to negative 64. So now we can complete the square here. So we still have this 9x squared minus 16 times y. Now to complete the square, we take half of the b value. Half of positive 4 is positive 2 squared, and this equals 144. So my next step, I'm going to eliminate this value here by dividing by 144. I need this to equal 1. If I have a hyperbola, that's always equal to 1 in the final step. So I divide by 144, divide by 144. So now I'm going to have 9 over 144 is going to reduce to 1 over 16. 16 over 144 is going to reduce to 1 over 9. These ones are just here, I'm just not writing them, but they are implied. And this is all equal to 1. So now I have my function. So let's begin with part A. Where is the center? The center is located, here we can see the x has not been translated, so it's at 0. Y has been translated negative 2, opposite sign as inside. So the center is at 0, negative 2. Okay, part B. The vertices. So in order to find our vertices, we need to make a graph. So let's go ahead and do that. Alright, so my center is at 0, negative 2. So here's the center. I'll label that C for center. Now, I want to see how far I'm moving on my x-axis and y-axis. These values here are going to tell me that. So we have a squared and b squared. A squared, b squared. The a value is going to tell me how much to move on the x-axis. So I take the square root of this, so that's 4. So I'm going to go 1, 2, 3, 4. And 1, 2, 3, 4. So the square root of the a value, or this is a squared, so the square root of a squared gives you a, which in this case is 4. So a equals 4. And of course, if you apply that same logic here, this is b squared, so b equals 3. So that tells me I'm going to go 3 in each direction. So up 1, 2, 3, down 1, 2, 3. So I now have my box for the hyperbola. Now in order to find out which way it goes, because how do I know it doesn't go here or here? You look at your leading value here. The leading term leads with x, so that tells me my hyperbola is on the x-axis. It opens on the x-axis. Okay, so now let's go back to that question. So we're looking for the vertices. So the vertices are going to be the points here. The vertices of the hyperbola. So our vertices, part B, are going to be at 4, -2, and at -4, -2. So there's part B. Part C is the foci. So now take our little equation that we talked about before, except with ellipses it's a little different. Hyperbolas are different than ellipses. So c squared is going to equal a squared plus b squared. The foci are on the outside of the box, so we need to add, get a bigger number. Ellipses, the foci are inside the circle, so we subtract here, just as a quick reminder. Okay, so our a squared value, if we look up here, a squared is 16, b squared is 9, this equals c squared, so c squared equals 25, so c equals 5. So that tells me that my foci are 5 from the center on each side. And you always move, of course, on the axis that's leading. So we're going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there are my foci plotted. And then in order to actually write their coordinates, I'm just going to add 5 to the center. So my foci are at 0 plus 5 is 5, -2. And then 0 minus 5, -5, -2. So we just added and subtracted the focal length of 5 from the center in order to find the coordinates of the foci. Okay, next, D, the length of the transverse and conjugate axis. So D, the transverse is our major axis when we're talking about hyperbolas. So we go 1, 2, 3, 4, 5, 6, 7, 8. So our transverse axis is 8. Our conjugate is our minor, so that's going to be 1, 2, 3, 4, 5, 6. Those are our axis lengths. All right, part E, endpoints to the conjugate axis. So the endpoints to the conjugate, if we look at our graph here, that's 0, 1, and 0, -1, 2, 3, 4, 5. The conjugate axis is the minor axis for the hyperbolas. So that's all for that one. That's these 2 points here. And then finally, part F, the equation of the asymptotes. So now, F, in order to find the equation of the asymptotes, we say y equals, what is the slope from the center to get to the corner? We have to rise 1, 2, 3 and run 1, 2, 3, 4. So our our slope is going to be plus or minus 3/4, which we can see here is b over a, just as a side note here. But it's going to be going in both directions, so it's going to be 3/4 this way and over 4 this way, so it can be a negative or a positive. So that's all we have to do, plus or minus. X, because the x was not translated left or right, we can just leave it as x. And then it was translated down 2, so we have to account for that by saying -2. If there was a translation, we'd put parentheses in around the x and put the translation in there. But the y translation is outside of the parentheses, or in this case, no parentheses. It's just sitting outside, telling us we're going down 2. So that's the equation of our asymptotes for this hyperbola. Zoom out and get all of the info. 4. There it is. Sorry about that. All right.